This tutorial will introduce you to the Cytoscape software and how it can be used to visualize sequence relationships in a large group of related enzymes. We'll be using Cytoscape version 3.2.0 along with sequence similarity networks downloaded from the Structure Function Linkage Database, or SFLD. If you're not familiar with the SFLD, you might start by watching parts 1 and 2 of this tutorial series, which introduce the SFLD. You can download Cytoscape networks for any SFLD subgroup or family. For today's example, I'm going to use the terpene cyclase-like 2 subgroup, which is part of the isoprenoid synthase type 1 superfamily. In the middle section of the subgroup page, I'm going to choose the Download Network tab. The sequence similarity networks in the SFLD are created using BLAST as a sequence similarity metric, so you can choose the BLAST e-value cutoff for the network you download. The ideal value will depend on the group you're looking at and the questions you're asking. You can also reduce the size of the network you download by specifying the maximum number of edges, which are BLAST similarity connections between sequences in the network. So, for example, if you choose a maximum of 250,000 edges, those edges with the most stringent e-values will be included in the network, up to a cutoff of 250,000. Any edges beyond that will not be included in the network you download. For this example, I'm going to go with the default settings for e-value and number of edges, so I'll simply click this Full Network button here. The download process does take a minute or two, but when it is completed, you'll have a zip file. When you unzip the file, you'll see 6 different files. The one that ends in the extension .xgml is the actual network file you're going to import into Cytoscape. I'm not going to go through all of the rest of the files, but I did want to mention that the README file contains an explanation of what each file is and how you might use it, so that's a good place to start. You must have the Cytoscape program installed on your computer to open the networks you download from the SFLD, but it's free, and you can download it by clicking on the download link on the Cytoscape homepage. As I said before, for this demo, I'm using Cytoscape version 3.2.0. Other versions of Cytoscape may be slightly different. I'm now in the Cytoscape program, and I'm going to import the network. I go to File, Import Network File, and then I choose the .xgml file that I downloaded and click the Open button. In this box, I click OK, and Cytoscape begins the import process. When the network is first opened, I have a very uninformative view. So the first thing I want to do is to lay the network out. There are many different layouts built into Cytoscape, and you can play around with them to see what you like best. One that we particularly like is Wi-File's organic layout, so that's what I'm going to use now. I go to Layout, Wi-File's Layouts, Organic. Depending on the size of your network, the layout process might take a minute or two. When the layout is finished, you'll see something like this. Each of the squares, or nodes, represents a single sequence in the terpene cyclase-like 2 subgroup, and each of the lines, or edges, represents a BLAST connection at least as significant as the default e-value cutoff of 1 × 10 to the minus 20th. In this layout, the edges between sequences represent only connectivity. That is, they show that 2 nodes are connected at the specified e-value cutoff. But while the lengths of the edges don't directly represent how distant these proteins are from each other, they do give a pretty good indirect approximation. Clicking on a node selects that sequence, and you'll see it highlighted in yellow on the network. Sequences are also associated with annotation information, which is pulled over from the SFLD. I'm only going to go over some of the available annotation attributes now, but if we look back in our download folder, this file called fullknitattributes.txt will give you a list of all the available annotations and what they mean. Back in Cytoscape, you can see the annotation information for the sequence or sequences that you've selected down in the table panel at the bottom of the screen. If you don't have any nodes selected, then by default, Cytoscape will show annotation information for all the nodes. Also by default, Cytoscape will show all the available annotation categories in the table panel. This can get a little overwhelming, so I'm going to press the Hide All Columns button, and then I'm going to use the Show Columns button to select a few specific categories of annotation data that I'm interested in. The Family column here lists the SFLD family classification, and related to that, the Family Evidence Code column tells you what kind of evidence was used to assign the functional domain to the family. The SFLD has a page that lists all the evidence codes and their definitions so that you know what they mean. We also have protein names from the manually curated SwissProt database, which we found to be quite accurate. And we have two different columns with length information. The full length is the length of the full enzyme, and domain length gives the length of that portion of the sequence thought to be part of the isoprenoid synthase 1 superfamily. The PDB IDs column lists the protein databank IDs for sequences with 95% ID or greater to a solved crystal structure. We also have species listed, and then a more general category that we call type of life, which can be useful if you're interested in enzymes from a particular taxonomic classification. As you've probably noticed, you can sort by any of these annotations simply by clicking on the column header for the annotation that you're interested in. One of the really nice features of Cytoscape is that you can color the network according to any of the annotation information you're interested in. So, for example, I could color the network according to the SwissProt annotation of each node. The appearance of the network is controlled by the style settings. I click the Style button at the top of the control panel to access these. I'm going to create a new style where I'll color by SwissProt annotation. I start by clicking the upside down triangle button and choosing Create New Style. I'll call my style SwissProt because that's what I'm going to be coloring by. And then I press the OK button. By default, all the nodes in the network are now colored red. I can change that default color if I don't like it by clicking on Fill Color in the default column. That brings up a set of color swatches. I'll choose gray for my default node color and click OK. As you can see, all the nodes are now colored gray. But what I really want to do is color according to the SwissProt protein name attribute. To do that, I'm going to use the Map column. As before, I'm going to click on the Fill Color box, but this time in the Map column. Under Column, I'm going to select the attribute I want to color by, which is SwissProt protein name. Under Mapping Type, I'm going to select Discrete Mapping, which means I'll have a unique color for each unique value of the SwissProt protein name attribute. I could select a color for each attribute value manually by clicking into the box next to the attribute name and then choosing the color I want from the set of swatches that comes up, but that gets a little bit tedious with so many different values. So I'm just going to have Cytoscape automatically assign the colors. To do that, I right-click on Column, then choose Mapping Value Generators. There are a few different color scheme generators I can choose from. I'll choose Rainbow OSC, and you can see that Cytoscape has automatically assigned a color to each attribute value, and these colors are reflected in the network. Now that Cytoscape has assigned the colors, if there are any that I'm unhappy with, I can change them manually. So scrolling through this, it looks like there are a few SwissProt annotations here that I don't think are particularly informative. So maybe I want these to be colored gray instead of these colors that Cytoscape has assigned. To do that, I simply select the annotation value or values whose color I want to change. I right-click, choose Edit, Edit Selected Discrete Mapping Values, and in the color picker, I choose the color I want and click OK. And as you can see, these are now colored gray. Because SwissProt is a manually curated database, which includes a fairly small number of sequences, the majority of the sequences in the network are gray, our default color, because they don't have SwissProt annotations. So it's a little bit hard to see the colored nodes in the network. So let's make the nodes with SwissProt annotations bigger, so they're easier to see. We're now done with this Fill Color section, so I'm going to click this upside-down triangle button to minimize it. As you can see, there are a bunch of other node properties in addition to fill color that I can change in this Style section. One of them is size. To size the nodes according to whether or not they have SwissProt annotations, I go through a very similar process to the one we just used to color the nodes. I click on the Map box next to Size. Under Column, I'm again going to choose SwissProt protein name, and under Mapping Type, I'm again going to choose Discrete Mapping. This time though, I want to make everything that has a SwissProt annotation a larger size. So I can simply select everything, right-click, go to Edit, Edit Selected Discrete Mapping Values, and then specify a number for my node size. I'm going to pick 100 and click OK. And as you can see, the colored nodes in the network are now much bigger and easier to see. As you might expect, nodes with the same SwissProt annotation tend to have similar sequences and thus cluster together in the network. For example, these dark green sequences here, which are aristolakene synthases. So coloring by SwissProt annotation gives us a really fast, easy way to get an idea of what reactions are catalyzed by enzymes in this subgroup and how they're related to each other. That is a very brief introduction to some of the basic features of Cytoscape. If you'd like to learn how we might use the program to make some hypotheses regarding the function of an uncharacterized enzyme, watch Part 4 of this tutorial series.